Okay, next we will learn about role of water in showing the properties of acid and alkali. Remember I told you for an acid to or an alkaline to show the properties it must have water, because water is the one that is going to ionize it, or you use the term dissociate it, because for an acid to show its property, it must have hydrogen ions. For an alkaline to show its property, it must have hydroxide ions. Okay, and this will only happen in presence of water. So I want you to learn some terms. Okay, because this is actually an experiment, and every year in SPM they will ask, regardless structure or essay, objective, every year they will ask. So there are different terms that use to describe if an acid is dry or if the acid has water. So if let's say I say glacial acid, like for example, let's say I say glacial and then I write the name of the acid. So let's say the name of the acid is ethanoic acid. Glacial ethanoic acid. It's actually, glacial means it's very pure, where there is no water. It's very pure and there is no water. So meaning no water means it's dry. So do you think it will show acidic property? It will not show acidic property. Aqueous means has water, it dissolves in water. So will it show acidic property? Yes, it will show acidic property. If I take the acid, I dissolve it in organic solvent. Like for example, I take hydrogen chloride, that means hydrochloric acid, pure hydrochloric acid. Instead of putting it inside a beaker of water, I put it inside a beaker of organic solvent. Examples of organic solvent are like propan-on, methylbenzene, trichloromethane. If you don't need to exactly memorize them, but at least know if the solvent, the name is not water. If it doesn't spell WATER, confirm it's all organic solvent. Can you see the name like very weird? These are all organic solvent. So if I take this and dissolve in all this, what do you think will happen? The HCl will still remain as molecule, because organic solvents are all covalent molecules, right? So this will also remain as molecules. So here cannot show acidic property. Now let's say I use the word anhydrous hydrogen chloride or anhydrous hydrochloric acid. What it means? Anhydrous means it's dry, so no water. Will it show the acidic property? No. So you need to know certain terms: glacial, aqueous, solid. Solid means no water. If there is the name of solvents, anhydrous, you need to know all this. The same thing applies for alkaline. Okay, so now let's go through the example in textbook. You must read the experiment. Okay, look at the experiment 6.1. This experiment is to study the role of water in showing acidic property. Your hypothesis: water is needed for an acid to show its acidic property. Presence of water, change in the litmus paper, the type of acid. Okay, look at the materials. Oxalic acid, you don't need to know what is oxalic, you're going to learn in Form 5. But all you need to know is, okay, what is the front one? What is the term used? Solid. I know solid means dry. Then I have distilled water. So what are they going to do? Can you see here? They are going to prepare a test tube filled with solid oxalic acid, and then they're going to put the litmus paper and see if there's any changes. And then another beaker, this plus water. So which one do you think will have an observation? For the first one, no changes in litmus paper, but for this one has changes in litmus paper, right? Okay, why? Later I explain to you why. Alkaline property is the same. Can you see? Litmus paper. Now this one, sodium hydroxide in water. Can you see the word solution? Solution means aqueous, got water. Over here, sodium hydroxide pellet. Pellet means it's a solid. Solid means dry. Okay, then you see the observation. Obviously, this one no changes. This one it will change blue. So how you explain them? To explain them, regardless structure or essay question, this is how you explain. Let's say it does not show acidic property. How would you explain? Glacial acid, or let's say it's anhydrous acid or a solid acid, they are dry acid. That's one mark. In this, the acid exists as molecules in absence of water. That's another one mark. Since there is no hydrogen ion present, no acidic properties are shown. The same you explain for alkaline. Let's say I ask you why solid sodium hydroxide pellet got no observation. Why the observation remains no changes? How you explain? Solid sodium hydroxide pellet are dry alkaline, one mark. Alkaline exists as compound. It's an ionic compound, right? It's a solid ionic compound because NaOH is actually an ionic compound, not a molecule. This is a metal, non-metal. So it's an ionic compound. It exists as an ionic compound in absence of water. Since there are no hydroxide ion, alkaline properties are not shown. That's how you explain. Okay, let's say if they ask you to explain for a positive outcome. In water, acid or alkali dissociate, or you use the word ionize. You cannot use the word breakdown. It's only either these two, into hydrogen ion or hydroxide ion. Hydrogen ion, hydroxide ion exhibit the properties of acidic or alkaline. That's all. That's how you explain. You're just going to tell this term. Okay? So that's how you explain about role of water in acidic and alkaline property. Now before I end the video, I also need to tell you that acids and alkalis in solution or in aqueous, when they dissolve in water, they will conduct electricity. Why? Because there's presence of freely moving ion. For example, HCl in water, okay, let's say it's an aqueous solution. That means in water, it breaks into like this, right? Can it conduct electricity? Yes, because they are freely moving ions. But let's say I take HCl, I dissolve it in any organic solvent. Can I conduct electricity? No. Why? Because it still remains as molecule. There is no freely moving ions to conduct electricity. Okay?